Hey data files, welcome back to INST 314 Statistics for Information Science. We are now on the third video of the three-part series for Inference Part 2, Intro to Hypotheses, Power, and Effect Size. And this last one we'll be talking about an introduction to power and effect size. In the previous videos, we talked about the null and alternative hypotheses, we learned about alphas and p-values, and we're going to start with just by getting to the tip of the iceberg about power and effect size, because this is going to be a topic that we're going to be revisiting continually as we go through different types of statistical tests and hypothesis testing. So again, just to revisit, I can't stress this enough, the three big questions of statistics: how big is it, what difference does it make, and are we sure it's just not dumb luck? And when we talk about power and effect size, let's go ahead and get started. What we're really talking about is power means the probability of rejecting the null hypothesis when it is false. Well, wait a minute. Probability of rejecting? Didn't we just talk about that with p-values? Isn't that what a p-value is? No, it's not. Let's make sure we draw a distinction here. So a p-value is the probability of getting a statistical amount, some difference that we've observed, when we assume the null hypothesis is true. Okay? So if we said that everybody in the room has a certain height and we gauge all of our heights and we found that the average difference is 2 inches, then we can look up and determine what's the probability of finding a height difference of 2 inches given the sample that we have. And that is the p-value. And then we can use that against an alpha that says how much risk are we willing to take. If we find that our p-value is 0.03 and our alpha was 0.05, then we would say we would be statistically significant. And then we started talking about hypothesis testing with errors, type 1 and type 2, and this is where power is really starting to come in. So power is the probability of rejecting the null when it is false. This is where it differs, right? So this is what we're doing when we correctly reject the null hypothesis, and we express it as a proportion or a percentage. It is very common, especially if you go out into different research communities, to put forward your research ideas and somebody's going to ask you, what's your statistical power? They want to know what's the probability or percentage that if you get something that you find, that you're going to do it rightly. And so generally speaking, you want to have a power of at least 80%. Or 0.8, which we can infer to say 8 out of 10 times when you're doing your study, conducted over time, multiple samples, etc., that you're going to correctly determine your results as statistically significant or not. Okay, the p-value is when you're doing that individual study and says, I'm going to reject the null hypothesis or I'm going to fail to reject the null hypothesis based on my p-value and my alpha. The power says, am I doing it rightly when I determine to reject the null or not? So things that can affect your power. We're looking at saying the ability to find differences. And we're going to know, is your sample size large enough? The larger your sample size, the more it's going to be able to increase your power. Do you have different error rates? So what is your willingness to take on this risk? And the type 1 and type 2 errors, you're never going to really get rid of them completely. They are at odds with each other. The more you reduce for type 1, the more risk you're taking for a type 2. And as you look to prevent type 2, the more risk you're taking for type 1. So this is a fight back and forth that's going to affect your power. And so when you're looking at these things and you also have an understanding of how much variation should I have, that affects power. And you should look at these sort of things during the study design phase to help you figure out, do I need a stronger sample size? Do I need to take variables that I can account for different amounts of variation on? How much do I want to fight that type 1, type 2 battle on there? And when we do this in R, I want all of you to install the package PWR. Short for power, but there's no vowels, just PWR. We're going to come back to this package again and again as we do our different tests, because there's different functions inside of this that are going to match up with each test to help us figure out our power analysis studies. Now, when we're talking about these effect sizes, that's one of the big deals about power analysis. We said before in the previous video that you had statistical significance, and the statistical significance is what allows you to make these determinations to reject the null or not. Now, with effect size, this is what's falling into the how big is it? No, sorry, not how big is it. How much difference does this make, right? And how important is this? How the so what sort of answer? And so when you're dealing with these sorts of random samples, significance is not necessarily the same thing as importance, although I say the word substantive significance just so you hear these different ways that you might hear it out there in the real world, right? So what are effect sizes? Effect sizes are the magnitudes of the observed results, okay? It is the size of these differences that we're finding. And there's two ways you can find them: unstandardized and standardized. Unstandardized is the raw score difference. We have y, we have x, we take a subtraction from each other, and that amount is the unstandardized amount. A standardized means that we have done something to it, that we have stripped away its units of measure, and it allows us to compare it with other standardized values of the same measure. So if I was to say that the average temperature in, let's say, the month of February is 25 degrees, and today is 30 degrees, we see that there's a 5-degree difference. And that would be an unstandardized amount because we're still talking about it in terms of degrees, 5-degree difference. And a standardized amount would pull that off, and it would become just a number that we can compare to other standardized versions of temperature to see which one is bigger, right? Then it won't matter if it was originally measured in Fahrenheit or Celsius or Kelvin. It would just be a standardized number that we could just compare across these metrics to see which one was larger than the other. Now, when we're reporting these effect sizes, it's good to know how it works in terms of its practical significance. Take the observed effect and relate it back to the context, right? Look at the problems and the things that you're asking about and say, all right, here's the difference that I have. How much of a big deal does this make? If we're talking about, before I mentioned a 2-inch difference in height, is it a big deal that across our classroom we have an average of 2 inches in height? Now, if we have a fairly representative amount between men and women in the classroom, men on average tend to be taller than women, and so it might not be that big of a deal that we have a 2-inch difference in height if there's an equal number of them, because we would expect men to be taller and we're going to find some differences. So that might not be too significant. So let's break this out when we're talking about significance and importance, how this might play out. Again, we've got the classic 2x2 table, and on the rows we have if we are important or not, and in the columns we have if we are significant or not. Now, if you are significant, statistically significant, and your findings are considered important, huzzah! You are probably going to have a trending topic. Somebody wants to know what it is you found. Yay! If you are significant but unimportant, that means you found something that is highly relevant, that you can generalize it back to the population, but nobody's going to care. We can think of it like that 2-inch difference in height. That, hooray, there's a 2-inch difference in height. This is a real and true difference, or so we are believing, because we can't say it's absolutely true. And so, great, but not that many people are going to care. Now, if you're not significant but important, then you have that sort of problem where you have some findings and they're a big deal, but you can't generalize it back to your population. You can only talk about it to the context of the sample that you're working with. And then the last one is you're not significant and you're unimportant. This is the sort of one that you're going to crumple your research up and throw it into the waste can and, kind of start all over a little bit, because not only could you not generalize it back to your population, but even the findings that you had weren't meaningful to anybody or anything in that particular regard. So keep in mind, significance and importance, it can vary depending on like what it is that you're looking at, and you can have different outcomes. And so keep these sorts of things in mind. Now, we can talk about going beyond statistical significance, and that's what I'm really drilling down here with this idea of meaningful differences. Look at the raw score of these differences, these unstandardized amounts. Put it into the context. So if you're looking at finding things that are not arbitrary, see if you want to talk about your effect to other effects, if they're on different scales, then we need standardized things. And this is where effect size is really coming into place. So think of things in terms of their metrics, how it works out, and the scales that they're working on. Place it into the context. So consider if we're using averages and means. The measures can be a little misleading, so let's take a look at this context. If we looked at a report from Diet and Exercise Experiment, and they said that the mean difference in weight loss between two groups is 60 pounds. Does that mean that everybody lost 60 pounds? Or did some lose 120 and some lose none? If you take an average, it's going to go ahead and show it's a 60-pound weight loss on average as you go across. So then the 60 pounds is our unstandardized amount, but a standardized number is going to help put that into some of our groups. So just keep in mind that when we're doing these effect sizes as well, the type of standardized tests are going to be dependent on what statistical test we're doing, and just like the power, we're going to go ahead and revisit it later. And with that, we are concluding the inference part 2, and I will see you all coming up with our first inferential test, chi-square.